Alright, the whole purpose of this video is to go over the practice exam for similarity right triangles, standard 6, 7, 8. Standard number 6 is fairly straightforward. Paying attention to the I can statements. Remember, the practice exam is not just about do you know how to do these problems. It's more geared toward do you know these standards? Can you actually follow through with the I can statements? This one says I can show that the side ratios are the same in similar right triangles, leading to the definition of trig ratios for acute angles. Well, please observe that this one asks us to explain why sine of h is equal to sine of k. When we take an exam, it does not have to be sine. It could be cosine, it could be tangent. It doesn't have to be angles h and k. Instead, it could be angles I or angles L. The work is virtually the same, but it's not going to just be memorize this answer and get by, because it's not just one possible way to check your understanding of the standard. All of them, though, look fairly similarly. First observation I'm going to write up. What is the sine of h? Okay, we know sine is opposite over hypotenuse. So what is the opposite of h? That's 8. And the hypotenuse is 10. Okay, that's where we get our sine. The next step, this stage right here, is where we are going to use the similarity. We will use the scale factor from similar triangles at this next stage. We're going back to one of our earlier units. What is the scale factor between the small triangle and the big triangle? Kiana, you told me 1.5. Where did you get that? Okay, you looked at having the corresponding sides 9 and 6. 9 over 6 gives you 1.5. That's not the only one that you could have used. We could have also used 12 over 8, would have given us 1.5. We could have used the corresponding pair 15 over 10 equal 1.5. Ultimately, it doesn't matter which pair of corresponding sides you pick, just as long as you still recognize that this scale factor is 1.5. To use it, we will multiply what is 8 times 1.5? 8 times 1.5 equals 12. What's 10 times 1.5? 15. At this particular point, we are going to make an observation. 12 over 15, that is the sine of angle K. This is a mathematical explanation for the proof. Not written up in sentence format, but written up in mathematical terminology. It's telling us our sine, we can rescale it. We can take the sine of an object, the sine of an angle, and when we rescale it using the scale factor, we get something that's equivalent. Well, that's why they're winding up the same. All we're doing is rescaling a ratio. We're using a dilation on the same thing. That's all it is. So my expectation for you, I expect you would have something like this written down. Progressing to the next one. Standard number 7 is entirely about the cofunction theorem. And so the first thing we have is use the cofunction theorem. So rewrite this thing. Sine of 30 is equal to what? And Josh quickly ran it out, cosine of 60 degrees. Why? How did you get that? We were remembering before that this is based on having the 30-degree angle, the 60-degree angle, and in particular, what we noted we had the rule before that you can take sine and turn it into cosine, and vice versa. Basically, you can switch back and forth between sine and cosine as long as you take the other angle. The other angle in our right triangle. Of course, getting that other angle came just from subtracting. And so we got very rapidly cosine of 60 degrees. The piece that I had written down in the blue, what Josh noted, that's all that I would expect you to have written down. I simply wanted to include the triangle and include the comments in the red to try to help you understand, if you didn't already, where that answer came from. Check our next I can statement. I can explain the relationship between sine and cosine of complementary angles. Before you can explain it, you have to say what it is. So let's just start here. Question. What is the relationship between sine and cosine of complementary angles? Basically, it's this thing. It's the cofunction theorem. Yeah, the cofunction theorem is the relationship. So what does the cofunction theorem say? So we can switch sine and cosine just as long as we take the other angle. So how do we write that up in a sentence format? Or how do we write that up in mathematical format? Because you can write it with a math sentence, you can write it with an English sentence. As long as you're saying what the relationship is, you're okay. For this particular one, to write it up in written English, the sine of an angle equals the cosine of its complement. Once again, the stuff written down in blue is a valid answer. As the example we had of this, sine equals cosine as long as we take the complement, the other angle. It's exactly what we were doing before. We're just writing it up in sentence format instead of an example. Alternatively, if we didn't want to write it up with the written English, we can do it with algebra. The sine of an angle equals the cosine of its complement. Or we just subtract the angle off of 90. Either of those two things in blue is a valid answer, because they're telling you the same information. It's just the answer written in sentence format or math format. Question number 4 is the one that most directly relates to the standard number 7. Because standard number 7 is about explaining the cofunction theorem. Why is it true? And that's what this problem asks us to do. So let's run through the directions and list everything. Draw a right triangle. I'm assuming that's not going to give anybody trouble. Okay, there, I have a right triangle. Label the sides with an appropriate Pythagorean triple. So what does that thing mean? What is a Pythagorean triple? A Pythagorean triple, remember, are 3 numbers that fit the Pythagorean theorem. So what are 3 whole numbers? No fractions, no decimals. Most common one, Moses remembered 3, 4, 5. And 5, 12, 13 is another really, really common Pythagorean triple. And frankly, if you can't remember either one of them, hello, you've got 2 examples sitting right there. 6, 8, 10, 9, 12, 15. They're both Pythagorean triples. So label them however you want. What numbers do you want to use? Okay, so we'll take 3 and 4 and 5. Obviously, my drawing is not to scale. It's a 3, 4, 5 triangle. Doesn't actually look like this, but we don't need the angles. We don't need it to look perfect. Okay, let's start with the piece, because the directions now say explain the relationship. We've already said the sine of an angle equals the cosine of its complement. This problem asks us to explain why. Why is this thing true? Now, the pieces that I'm going to write down here in the red, you don't necessarily have to have written. I'm putting them down as notes because it's the thought process. This is what you should look at. This is what you should think. What is the sine of theta? We don't have an angle theta. So pick one. Pick an angle and call it theta. Do you want the top angle or the bottom angle to be theta? Okay, you pick top, which would make the bottom angle the other one, the complement. So in this instance, what is the sine? Recognizing that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. What are they? What is the side length that's opposite of theta? What number? That's 4. And the hypotenuse is 5. If we switch angles then and start thinking about the angle 90 minus theta, which leg is which leg is adjacent to this complement? Adjacent is next to, so once again that's 4 over 5. Please notice that the pieces that I put down in the red are not an explanation. That's not going to work as an answer. That's just verification, not explaining. It's still worth having written down for you to study, because what if the directions change? What if the directions get changed from explain to verify? What if the directions say verify and explain? You of course have to make sure you pay attention to the directions, because the directions tell you what you need. The stuff in red is verifying. We still have not explained it though. But that's still the idea. Why is it that we're getting this 4 matching 4? We could write up the explanation. Sine of theta equals cosine of 90 minus theta, because opposite of theta and cosine of 90 minus theta they're both referring to the same side, the same leg. In our drawing, it has a length of 4. That's why. Hypotenuse is, of course, going to match hypotenuse. So denominator matches denominator. Because we're using 2 different names for the same side, we know numerator matches numerator. So if your denominators are guaranteed to match, being the exact same thing, and the numerators are guaranteed to match, being the exact same thing, of course you wind up with the same fraction every single time. The stuff written in blue is an explanation. The stuff written in red is a verification. Make sure you pay attention to the directions, because depending on what they ask, you could be doing one of them or both of them. Progressing forward, we'll note similarity in right triangle standard number 8. I want to emphasize all our I can statements. Use sine, cosine, tangent in word problems. Use inverse sine, inverse cosine, inverse tangent in word problems. Use the Pythagorean theorem in word problems. And combine sine, cosine, tangent, inverse sine, inverse cosine, inverse tangent, Pythagorean theorem in word problems. So what do you think you're going to encounter? Word problems. The standard is word problems. You should expect to see nothing but word problems then. That's what the standard requires. Basically though, this standard is just a... Come on, man. Rick, you're killing me here. This standard is just a summary. We've done sine, cosine, tangent, Pythagorean theorem, the inverse of the the converse of the Pythagorean theorem, where we'd use it to classify acute, right, obtuse. Figure out angles, combine them all together. Basically, this is use any tool you have at your disposal. Special right triangles, trig, Pythagorean theorem, whatever you've got and get an answer. Of course, that makes it both easy and hard because you get to do whatever you want. Pick any strategy that works and just get the answer. That level of freedom, of course, makes it both easy and hard. Let's continue here, though. How do we solve word problems? What's the first thing we always try to do? Draw a picture. If we can get a picture, then we can start looking at it and say, ah, this is what I need. So let's go from here. The pilot needs to begin her descent when a plane is 7.5 kilometers above ground. What does this tell you? What does that look like? Okay, you guys get to make fun of my horrible drawing. Ooh, airplane! Yeah, I know, it's bad. But we've got airplane. What does this piece mean? What does that look like? Okay, and people are showing me straight up and down is that 7.5 kilometers. We know that's going to form a 90-degree angle then with the ground. And so we could go over and note at some point they've got to land at an airport. So we'll put it together and say, voila, we have a right triangle. Continue the problem. The next piece tells us it's 200 kilometers straight to the airport. Where would that go? 200 kilometers straight from the pilot to the airport. Yeah, that's the hypotenuse. And so the next piece we're looking at what angle should the pilot descend so she can fly in a straight line? Well, I'd like to point this part out. Angle of descent. The angle of descent is another way of saying the angle of depression. Because it's an angle going down. One thing to keep in mind, an angle of depression, an angle of descent is built along the horizontal. The most common mistake students have with this problem is thinking that they're looking for this angle. They're not. This problem is not looking for the black angle. It's asking us for the angle of depression, its complement. Now, it's not a problem. We can still figure out what this first angle is. What variable do you want to use for it? What symbol do you want? Okay, smiley face it is. Angle smiley face. We can figure out angle smiley face and just subtract it off of 90. We know that'll work. So let's run from there. What could we do? What kind of equation can we build to get angle smiley face? Why cosine? Well, what is this piece of 7.5? That's adjacent. Kobe told me that we also had hypotenuse, and so you're absolutely right, Kobe. Given that we have adjacent and hypotenuse, we can take the cosine of angle smiley face, angle messed up face, I guess. Angle smiley face is 75 over 200. Now what? Yeah. We need to get smiley face by itself, which means we have to get rid of cosine. And to get rid of cosine, we'll pair it with cosine inverse. So thus, we have angle smiley face is cosine inverse. And I can see you're already grabbing your calculators. What is the cosine inverse of 75 over 200? And Ethan's given me 67.97 degrees. So this piece is 67.97. Once again, though, this is the one we wanted. So how do we get it? Just subtract it off of 90. 90 minus 67.97 would give us 22.03 degrees. So that's what she needs, a 22-degree angle on her descent. An object worth noting, this is not the only way to do it. If you remembered that we had parallel lines, alternate interior angles are congruent. And so we could have instead said, figure out this angle theta, which would have been our answer. And if we chose to work with angle theta, then we could have had sine is equal to opposite over hypotenuse. Continuing down this path in the yellow is a second way to get the correct answer. Pick whatever strategy works, though. Let's continue to our next one. 4 blades of a helicopter meet at right angles and are all the same length. The distance between 2 tips of adjacent blades is 36 feet. How long is each blade? Round your answer to the nearest tenth. What does this thing look like? What is it telling us? Okay, so you get to make fun of my crappy pictures again. Helicopter, woo! 1, 2, 3, 4 blades. Our helicopter has 4 blades. And we're told they meet at right angles. So this is what's going on. We have 4 helicopter blades meeting at 90-degree angles in the middle. We are also told they're all the same length. So each blade is the same. We want to know the distance between the 2 tips of adjacent blades. So this is telling us if we have adjacent blades from tip to tip, what is that distance? Okay, that distance is 36 feet. Finally, the question asks us, how long is each blade? So we want to know the length of the blade, knowing that they are the same length. So how are we going to do that? What information does it give us, Ben? We know the hypotenuse is 36. We know the two legs will be the same. Yes. The important observation you have to recognize here, because the legs are the same, the angles will be the same. Basically, you must recognize that makes this a 45, 45, 90 triangle. Well, now what? We have a 45, 45, 90, and basically this is where you get to start picking more of your strategies. We know that a 45, 45, 90 had this relationship. The length of the leg multiplied by the square root of 2 will equal the hypotenuse. And so if you want to do it this way, it is absolutely valid. You can solve that equation and get your answer. It works. There's nothing wrong with using it. What if you don't remember the equation, though? Well, in this instance, you're not screwed, because we can still look at it and say, based on our 45-degree angle, opposite and hypotenuse, we can still build an equation that says the sine of 45 degrees equals opposite over hypotenuse. And we can build a separate strategy, a separate equation. It doesn't matter which way you choose to use it. You can use the special right triangle properties. You can use general trigonometry properties. As long as you recognize that you've got a 45-degree angle, you have multiple avenues for success. Just pick the one that you like best. So you tell me, which one do you want to finish? Using the sine or using the square root of 2? Sine. Using sine? Okay, so to solve that one, we just have to multiply by 36. And so we have x is equal to 36 multiplied by the sine of 45 degrees. Put that into our calculators, and what do you obtain? Okay, Ethan gave me 25.45. Since we're supposed to round that to the nearest tenth, we have 25.5 feet. And we're done. Of course, if you picked the special right triangle properties, you have got the same answer. You just pick the one that you like best. Let's continue here. One method that meteorologists could use to find the height of a layer of clouds is to shine a bright spotlight directly up into the cloud layer and measure the angle of elevation from a known distance. Find the height of the cloud layer to the nearest 10 meters. So basically we're looking at it and saying, here's our triangle. We have a 35-degree angle. We have a known distance of 525 meters. Spotlight's going straight up. And what are we trying to figure out? Find the height of the cloud layer. So we're looking for height. Well, based on this information, what can you do with it? Cosine of 35 is opposite over hypotenuse. Well, we have opposite and not hypotenuse. Yeah, since we don't have hypotenuse, cosine isn't the right one to go with. We have opposite, we have adjacent, that's tangent. So we'll run from here. We'll continue. What are we going to do to solve it? Multiply by 525. And so we have h is equal to 525 multiplied by the tangent of 35 degrees. Putting that in, we get 367.60. And we're going to lose some points on this one. Why? Well, our work is good. What did the directions tell us to do at the very, very end? Round your answer to the nearest 10 meters. We didn't round it to the nearest 10 meters. Rounding it to the nearest 10 meters as we were instructed, 370 meters is the height. It's a little thing, but frankly, why would you want to lose, a couple points just because you didn't read the directions? Question number 8. In shop class, you make a table. Sides of the table measure 36 inches. Okay, so 36 inch, 18 inch, all right? And the diagonal of the table is 43 inches. Is the table square? Please note that's not saying, is the table a square? Because obviously with 36 and 18, the shape is not a square. In construction, though, square is a term that means it's a 90-degree angle. You've got 90-degree corners. So this problem is asking us, is this a 90-degree angle? Yes or no? With this problem, the thing that should pop into your head, the inverse of the Pythagorean theorem. We were discussing before that we can compare c squared with a squared plus b squared, and that there are 3 options available. It's possible for it to be less than, equal, or greater. And this stuff in yellow, I don't expect you to have written down on your exam, but this is the thing that should pop in your mind. This is the knowledge that you should have. You should know that if c squared, the supposed hypotenuse squared, is less than the sum of the legs, that will cause it to be an acute triangle. If it's equal, you actually get a right triangle, and if it's greater, it causes it to be an obtuse triangle. This is a problem, then, that's asking us, which case is it? It's not too bad. We'll just plug in our numbers and see 43 squared compared to 18 squared plus 36 squared. Let's grab our calculator and start crunching the numbers. What's 43 squared? And I'm told 1849. 18 squared plus 36 squared, 1,620. So let's compare them now. 1849 is greater than 1620, so to write it up, no, a table isn't square. Because a corner is an obtuse angle. And we don't know about all the other angles. Maybe another angle somewhere is with a different angle and a different pair of sides or something. Maybe it would wind up that way. Who knows? Maybe the table is a rhombus. Not a rhombus. A trapezoid shape. Or maybe it's a parallelogram shape. We don't know what shape it is, but we are certain it's not a rectangle. And here's our last problem. We'll start looking at the pieces. Firefighter on the ground sees a fire break through a window near the top of the building. Voice. And we're going to start running through pieces and note the angle of elevation to the windowsill is 28 degrees. That is simply telling us this is a 28-degree angle. The angle of elevation to the top of the building is 42 degrees. That's telling us the 42-degree angle in the picture. Firefighter is 75 feet from the building. which is simply telling us this piece is 75. Her eyes are 5 feet above the ground. So we have all of that information. Basically, all the stuff that I've highlighted there is just telling you here's where the picture came from. Just describing what came from where. Now we have to actually start looking at the piece and say, what is the distance from the roof to the windowsill? Where is that? From the roof to the windowsill distance. Where is that in the picture? From the roof to the windowsill. This is what we're searching for. So I'm going to call it X. Once we know the letter's not important. But I picked X, just because I like X's. Okay. Well, we'll note that piece of X is not a part of a right triangle. That's not an, if I start looking at this triangle, that's not 90 degrees. And so what can we do then? When we had problems like this in our homework, the strategy we noticed was that we could create an entire right angle here. And so we can call this piece Y and the entire length Z. So we're observing X plus Y equals Z. So the top piece plus the bottom piece equals the total length. And when we had these types of pieces in our homework, we recognized that we could start off with a triangle right here. We could start with this right angle and figure out the length of Y. Let's build an equation to get Y. Well, what trig identity would we be able to set up? We know that we have a 28-degree angle. We know that we have a 75 length side. That would allow us to build it and say the tangent of 28 degrees equals opposite over adjacent. So Y is equal to 75 multiplied by the tangent of 28 degrees. And after using our calculators, what does that give us? And I'm being told that's 39.87. Okay, so great. We now know the value of Y. We can build on this further by determining the length of Z. This whole piece could come together. And note that in the blue, we have another right triangle where we have a 42-degree angle, a side length of Z, a side length of 75. So virtually identically, we'd have the tangent of 42 degrees equals opposite over adjacent, telling us Z is equal to 75 multiplied by the tangent of 42. And putting those together, 75 multiplied by the tangent of 42 would give us 67.5, and what's the next digit? 67.53. All right, so we have those two pieces then, and we can put them together. X plus Y equals Z. What would you have to do to solve it then? Okay, after we subtract off that 39, 67.53 subtract 39.87, that's 27.66. Would you verify my arithmetic, please? And so there we go. We know that it's 27 feet, 0.66. Well, 0.66 is 2/3, so 2/3 of a foot is 8 inches. If we wanted to write it up, 27 feet, 8 inches. That's how far they would have to rappel down from the roof to get into this building. And thus we're finished, noting that we've got all the components of our exam. Please make sure that when you're studying, you don't study only these problems, but study the standard. You should expect sine, cosine, tangent, inverse sine, inverse. You will have to use trig functions, you will have to use inverses, you will have Pythagorean theorem, and you'll have to start combining the pieces to solve more complex problems. You will have to explain why the cofunction theorem is true. You will have to explain why it makes sense to talk about the sine of an angle, or the cosine, the tangent.